Yeah, good morning all students. In last lecture we have seen about Hall effect. I stopped up to Hall effect. Let me recall once again Hall effect and get into the other topics. So what is Hall effect? Hall effect transducer is nothing but it is used to measure the magnetic fields, and the Hall effect was discovered by E.H. Hall in 1878 from an experiment using metal segment, and it is named after named after the name of the inventor Hall. So it is termed as Hall effect. So the semiconductor devices which are made for the use in detecting magnetic fields are termed as Hall elements or Hall generators. That is, the semiconductor material which we place between the magnets in order to measure the magnetic field are termed as Hall elements or Hall generators. So some of the examples of your Hall elements or Hall generator is indium antimony and gallium arsenide. So from that we measure the voltage, Hall voltage. From that only we measure the magnetic field. So Hall voltage is given by the formula 1 divided by D into B into IC into RH, where RH is your Hall constant, B is flux density, IC is electric current which is passing through the semiconductor material, and D is the thickness of the semiconductor material. So from this we can find the value of Hall voltage and we can measure the magnetic field. And here is a diagram of your Hall effect operation for N-type as well as P-type. This is what your Hall element or Hall generator. So from this we can understand the majority charge carriers are holes here. So that is electrons here. So it is termed as the N-type. The majority charge carriers holes here. So it is now termed as P-type. So this is what the direction of your flux density. So when some battery supply is given to the battery, two magnets are placed either side of your semiconductor material. So because of that only your electrons are flowing through, that is current flowing through the semiconductor material will get deviated and passing through this volt to the voltmeter. So from that we find the Hall voltage. And advantages of Hall effect transducer are it is going to operate at higher speeds than your mechanical points, and whereas it can be operated up to 100 kilohertz, and it can measure wide range of magnetic fields. It is going to be very stable, reliable and long lasting, and it is going to have high resolution. And one of the main advantages is the size of your Hall effect transducer is small. And coming to disadvantages, it has very low output drive capability. That is, output drive capability is going to be very low for your Hall effect transducer, and it is difficult to operate in strong external magnetic fields. We know that we are going to measure the magnetic field of your magnetic fields with the help of Hall effect transducer. So if the magnetic field is going to be very strong, it is difficult to operate. Why? Because the device cannot able to withstand that much amount of magnetic fields, and it is going to show very less accurate readings. And coming to applications, it is used in brushless DC motor, that is for the operation of finding the speed, and vending machines and proximity detectors, shaft position sensors, speed sensor, motor control. For speed sensor, that is in order to control the speed of motor, it has been used. Your Hall effect transducer is used, and valve position detector. These are some of the applications of your Hall effect transducer. And coming back, the next topic is mechanical transducer. A mechanical transducer or mechanical elements. That is the main point. Mechanical elements that is used to convert one form of energy into other form of energy. Generally, transducer is going to convert one form of energy into other form of energy. If that conversion process is done with the help of mechanical elements, it is termed as mechanical transducer. So some of the most commonly used mechanical transducers are your bellows. Here are the mechanical transducer elements. So first one is bellows, Bourdon tubes, probing rings, load cell, diaphragms, spring. This diaphragm we already have seen in capacitive microphone, how it has been acting. And here are the diagrams of your mechanical transducer. These are pillows which when we apply pressure, it is going to compress and elongate. From that your meter reading is being calibrated. They have calibration scale. And here is the Bourdon tube in which the pressure is applied through this tube, and in turn it is going to change the measurement of the measuring quantity. With the help of this calibrated scale, we can understand the value of it. And probing rings, this is the probing ring. When force is applied in this directions, it is going to change the value of your pointer. Similarly, load cell, diaphragm, and spring. All these are mechanical elements which is going to convert one form of energy into electrical form. That is why it is termed as mechanical transducers. And coming to the next topic, measurements. And what is measurement? So it is the result of comparison between a quantity to be measured and the predefined standard. We are going to take readings with the help of some measuring instruments, and those values is being compared with the predefined standard value. That is what it is termed as measurement. So instrument which is used for the purpose for this purposes are called as measuring instrument. That is instrument which is used to give comparison between your quantity of measured and predefined standard is going to be termed as measuring instrument. So some of the basic requirements of your measuring instruments are: it should not affect the quantity to be measured, and when it is connected to the circuit. So if you consider, if we are measuring a voltage, when the measuring device, it should not observe more amount of voltage, so it might give some error to the reading. So it should not affect the quantity to be measured when it is connected to the circuit, and the power consumption should be very small. For the operation of your measuring instrument, the power consumption should be very small, or even it should not consume any amount of power in order to get accurate values. So these are some basic requirements of your measuring instruments. So in general, your electrical and electronic instruments are classified as with analog and digital instruments. So generally, we have seen a lot of measuring instruments in laboratories. That is your ammeter, voltmeter, multimeter, everything is going to be the measuring instrument. Analog instrument is nothing but it is going to have analog scale, a calibrated scale, and a pointer over it. Even the clock what we use in our home is going to be your analog instrument. Whereas if you use 7-segment LED clocks, it is going to be your digital instrument. And coming to the methods of measurements, it is classified methods as direct comparison and indirect comparison. Where direct comparison is nothing but when the unknown quantity is directly compared to the standard quantity. So no intermediate channel to compare the value with the standard quantity, then it is termed as direct comparison. So whereas indirect comparison, from the word itself we can understand there is a parameter to be measured is compared with the standard with the help of some calibrated system. Some intermediate system is being included in this measurement, and therefore this is termed as indirect comparison method. That is comparison between your parameter to be measured with the standard value. And coming to types of measurement, it is classified into primary measurement, secondary measurement, and tertiary measurement. So primary measurement is similar to your sort of your direct comparison method. That is, you are going to compare directly with the reference value or standard value. So example for this is when you are using a scale for the measurement of length of some line, it is going to be a direct comparison. It is straight away the length is measured with the help of the length segments. That is why it is termed as direct comparison. And coming secondary measurement, one conversion made and compared with the reference. That is, we are going to convert, consider if it is going to be a mercury thermometer is the best example for your secondary measurement. That is, the doctors generally use a thermometer. Nowadays they are using sensor type thermometers. In older days they have used a glass tube in which mercury is filled. So it is used to measure the temperature, right? So in mercury thermometer, they place the thermometer in order to measure the heat temperature of your body. So when the temperature increases, gradually the mercury mercury length is being increased in the scale what is being which has been there in the thermometer. So from the length of that thermometer, mercury value, we are going to measure the temperature. That is why there is one conversion. That is, temperature is converted into length, and from that we are concluding the temperature value. That is why it is termed as secondary. That is why it is termed as secondary measurement. And coming to tertiary measurement, there will be two conversion made as and it is then compared with the reference value or standard value. So what example for your tertiary measurement is, thermocouple. In this, the temperature is converted into voltage first, and then the voltage is converted into length. From the length of that length value, we can identify the temperature. That is, the scale will be of in the value of degrees. That is, it can be 10 degree up to 100 degree or something. So by increasing the length, the voltage increases the length, and with the help of the length, we've identified the value of temperature. This is what a tertiary measurement means. And the types of instruments your types of instruments. Instrument is a device for measuring the value or magnitude or a quantity or a variable. We all know this. So it is going to either measure a value or magnitude of some quantity. It can be either an analog signal and a variable. Then it is termed as instrument. And coming to the types of instrument, already we have seen some types. Here are some other types based upon the thing which it is being measured. So first one is mechanical instrument, second one is electrical instrument, and the third one is electronic instrument. So mechanical instrument is the first type of measuring instruments that was made made previously in the long years ago. So it is the first measurement in nature. Still it is being used. Still we are using mechanical instrument. That is, we have seen the mechanical transducers. That mechanical transducers are the mechanical instrument. That is, the mechanical element is used to measure some quantity. That is what mechanical instruments. And coming to electrical instrument, these electrical instruments are used nowadays, but it is going to depend on mechanical instruments. Why? Because the one more advantage of your electrical instrument, it is going to be very rapid and in indicating the output. That is, at the same instant we can get the value very quickly. That is what rapid in indicating output, but it is going to depend on mechanical instrument. That is what the disadvantage of your electrical instrument. And coming to electronic instruments, it is going to measure some value with the help of some electronic quantities. That is why it is termed as electronic instruments. So example for your electronic instruments is cathode ray oscilloscope. We have seen cathode ray oscilloscopes in our lab, where the oscilloscope consists of some electronic instruments inside it in order to measure the value of voltage, power, anything. It is going to display some output waveforms. It can be either any type of either AC or DC waveforms. It is going to give the output. So that is what is termed as electronic instrument. Coming to classification of instruments, your instruments is classified into absolute instrument and secondary instrument. So what is absolute instrument? The example for your absolute instrument, from the name itself we can understand, is going to give the absolute value then and there itself without any additional reference, and therefore it is termed as absolute instrument. So that the tangent galvanometer and relay current balance, this is going to give absolute values. That is, the tangent galvanometer is showing the instant value then and there without any additional reference needed. And coming to secondary instruments, your examples are voltmeter, ammeter, and pressure gauge. It needs some secondary inputs, that is some conversion method in order to get the value of your output, quantity to be measured. And these are some of the examples for your analog and digital instruments. Here, as I said earlier, your clock is one of the analog instrument, and your multimeter is going to be one of the digital instrument. It is giving digital outputs. So this is the clock which has 7-segment display, and it is going to be digital clock. And the next topic is analog instruments. The next topic in your syllabus is going to be analog instruments. So analog instrument, the output is going to be the continuous function with respect to time. That is what that signal is termed as analog signal. So with the system or instrument which is going to measure analog signal is termed as analog instrument. So example for your analog instruments are ammeter, voltmeter, wattmeter, and power factor meter, etc. So classifications of your analog instruments are indicating instruments, recording instruments, integrating instruments. So indicating instruments means it is going to indicate the value that is to be measured. So in ammeter it is going to measure, that is, it is going to indicate the value of current, and voltmeter it is going to indicate the value of voltage. This ammeter and voltmeter we have seen in laboratories. So those are indicating instruments. And recording instruments are nothing but it is going to continuous record of quantity over a specific period of time. So, for example, if we have gone to industrial visits to some power plants, in control room there will be a voltmeter. That voltmeter is going to record the voltage which is being either supplied or